So we are actually talking about methods now. So method essentially is, so like assuming you want to take a task and want to repeatedly do that task, we use a method to do it. That's an example of what, method like you are adding integers, finding the sum from 1 to 10 or from 20 to 30 or from 35 to 45. What does that mean? Is essentially if you want to do 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10. You want to create a function that does that. How you will do it? You'll say, I want to create a function essentially which takes this number. So you say for int equal to 0, I less than 10, I plus plus, and then do. So you start with int sum equal to 0, and then you can say sum is equal to sum plus I, and then return sum. This essentially is a function that returns a sum of 1 to 10 essentially. So that's an example. That said, so what you can do similarly, take int equal to 0, sum 0, int I equal to 1, I less than 10, I plus plus, and then sum I plus equal to 1, and that gives you the sum. Now you can put all of this in a function so that you can actually do a start point and an end point and then calculate the sum between start and end point. In this case, the start point is 1, end point is 10. In this case, start point is 35, end point is 45, and that actually gives you sum of both essentially start and end, and gives you start and end for something. There we go. So that basically outputs the sum. The principle is the same. That's the problem. Now you can, so these are basically parts of code that actually give you sum from a particular value to a particular value. Obviously, when you start the sum will start with 0, and then you keep on adding to the sum, and that actually gives you the final sum. You can also write this as sum is equal to sum plus I, which is the same thing as sum plus equal to I. So the solution of adding basically, so you have a start, you have an end, and then you're taking int start point to end point and then add. So this function will pretty much calculate 1 to 10, it will calculate 20 to 30, it will calculate 30 to 45. So it will calculate all these values essentially to give you what the answer you need. So instead of typing this so many times, like once, twice, three times, what you do is you write a simple function like this, which you can actually pass here and just put in the values, and that will give you the answer for all one. So two values. So this adds between 1 to 10, this adds 20 to 30, and this has 35 to 45. So that's how it actually goes. That said, few things we're going to talk about is parameters. So these are basically parameters that you're actually passing in. So this is the parameter. So if you say parameter, this is the parameter of a function, basically. This is the function name. This is the parameter. So we'll talk about few things. We'll talk about return value. So in this case, this is your return value. So your return value. So you are returning the sum. In this case, you are returning the sum as return value int. It basically says return whatever you are returning out of the function. Okay, so few other things you pass assignment by value. It's modular, easy to debug. So we'll be talking about few of these things. So now this is basically trying to find a method which takes two numbers and tries to get whatever the maximum value is from both the numbers. That said, you have the result basically telling you what the maximum. So if one A is greater than B, then your return value becomes A because A is bigger. If B is greater than A, your return value becomes B because B is greater. So what you do is, so result, the value that you're trying to return becomes number 1 if number 1 is greater. It becomes number 2 if number 2 is greater. and that is returned as result essentially. This is how the function's called. This becomes your answer because that's this return value being returned here, and these are the two parameters that you actually put in to see which one's greater than what. Similarly, you see, so you have modifiers here. This is the type of return value, this is the name of the function, and these are the parameters. So this is the parameter list essentially. So this is essentially what? So if you have four values going in, so that becomes your parameter list. Okay, and this is basically your method, and this is your return value. So, and this is your method signature. So method signature basically tells you the max int num1 comma int num2. This becomes your method signature. It tells you how you need to use the method. Okay, so that becomes your method signature. Similarly, so method signature is a combination of method name and the parameter list. There you go. So that's what it says. Method name, the method name and the parameter list. So that's your parameter list. And that becomes your method signature. So you have to keep in mind what a method signature is. Okay. Method header is basically this essentially. This is the method name. This is the return value type. And this is your return value. And this is how it's actually called. And that's called invoking a method. So when you call a method, it is called invoking the method. So variables defined in a method are called formal parameters. So these are formal parameters. This is what is actually passed to a method so that it can calculate what it needs to calculate. So these are formal parameters. So then the next thing is actual parameters. So actual parameters are when you actually use the method and while invoking, you pass those parameters in. Those are actual parameters. So that's the argument, that also called argument, that is actually used in a function when you invoke the method. So you got to keep in mind, one, you are defining the method. Second thing, you're invoking a method. Invoking meaning using the method. Okay, and that actually is the actual parameter or argument. That's it. Return value type. Return value type is this guy, which is what it returns. Also, this is what it defines. This is what it is returning. So when you invoke, the value that you're getting back from this function is an int. How do we know? Because int is what was used to define, and the result which we are using from here is actually an int. So calling max. This program demonstrates calling the method max to return the largest of the int values. Okay, so what happens is you are trying to say which of the values are larger, I or j, essentially. So what happens? So when you call this guy, this piece of code actually executes. So this whole thing executes. So when you pass value I, which is basically 5, that goes in here, and 2 goes in here as they are passed here. From there, they're passed, and whatever the value comes out of this is returned here and is stored in K. So K is the value, and when you print, I will be this guy, J will be the second value that you use, and K is the answer to both of them. So I is now 5, J is now 2, essentially, and when it invokes max ij, so the answer that actually comes back is the max value. So it passes I to num1, j to num2. So this is your num1, this is your num2, and it returns the max value between both of them. In this case, the max value is basically this result that actually goes here. So what do we have here? So 5 is greater than 2. So that means what is the answer? So this result value will be 5. That will actually go there. So the result now is 5 because it is basically this part of the code. Number 1 is greater than number 2. 5 is greater than 2. That's why this, in the if, this part gets executed, and from this part getting executed, the result is num1, and as the result is num1, the num1 is sent back to max. The result, which is basically 5, is sent back. There you go. You see 5 being sent back. And then I, j, and k are printed, which essentially are I is this value, j is this value, and k is this max value that we calculate from here. So, few things to know. A return statement is always required to return a particular value. Now, in this case, you're returning three values. You're returning 1, you're returning 0 or -1. Essentially, if n is greater than 0, you return 1. If n is equal to 0, you return 0. If n is less than 0, you return -1. You know? So, in this case, A is logically correct, but it has a compilation error because it thinks it's possible that the method may not return a value because you have an if, you have an else if, you have an else if. So, it's possible that there if there is it is possible that it may fall through and not have a value. That's why you need to not have this and have an else. That means by default it will, if nothing happens, it will give you an answer of -1. To fix the problem, what you need to do is if n is less than 0, compiler will think, so compiler needs to think with an else. It will think that's the another way, that's the last option there, and that's the default return value, so you have to be careful. So you can reuse methods from all classes. The max method can be invoked from any class besides test max. So we'll go to class names later. That said, activation method from main method k value, the result is basically, so it activation record max value, it record for main, so it goes back to main, and then it activates and gets back. So how it works is the main method invokes the function. The max method is invoked, which is basically the function. Once the max method is invoked, it executes. Once it executes, it returns the value of k, and then main method is finished. So this is how the stack actually works. So it first puts the activation record on there, then it puts the function, the maximum on there, then it checks for maximum, and then at the end, it, so it's step by step. Main method, then so main method is calling max. So when it calls max, max is calculated, then max returns the value back, and then the main method finishes. Then you get the value k. That said, I is initialized here, then the second one's initialized here, basically this value. So first thing is put into the stack, then the second thing is put into the stack. Then after that, k, it checks for k. Then when it checks for k, it calls the method. So it calls this from the main method. It calls this. This is called invoking. Invokes the method. As it invokes the method, it goes into this piece of code. So when it goes into this piece of code, those values actually go in. Num1 becomes 5, which is this guy, as it is passed from here. Num2 becomes 2, as it's passed from here. Those go into the stack, and then once you go into the stack, you get the value result, and they are, you say num1 equal to num2, you check for those, and the result basically is num1 because num1 is greater than n2. Your result becomes 5, and once the result becomes 5, it assigns to result, and that's what returns back to k. So you see k, and then you execute the print statement where k is equal to 5, j is equal to 2, and I is equal to 5. So void method is a method where it does not return any value. Essentially, it executes something and does not return any value. So if you say public static void main print, it will only print the messages, whatever message and how many times you want to print it, but will not return anything back. So you can actually use it. So when you see, so this is basically pass by value. So testing pass by value. So what happens is it checks. So it checks for, so in this case, it checks, basically there is nothing. So you have to put void in order for it to have no. So you can actually use n print ln. So you can actually just write this function without assigning it to any value because it does not return a value. Void says it does not return a value. So you can just say n print ln. Similarly, welcome to Java and 5 times. Computer science 15 times. So if you say this, this is not right because the first value needs to be a string. This is not a string, this is an integer, and this is a. So you have to be careful. So if you have two parameters, it's string and integer. The first value has to be string, the second value has to be integer. So you can do pass by value. So this is basically pass by value. So where these values are being passed to the function and it generates the answer. So modularizing code actually means that each method can be used to modularize code. That means it breaks the code up into in a such a way that each becomes a small compartment and each of these are reusable. Like I want to print in one case, I want to execute in one case, I want to find the difference in one case, I want to find the sum in one case. So each of this small piece of code is separate and can be reused. So that basically means modularizing code. Like if I have, so another one, so converting hexadecimal to decimal. So hexadecimal is essentially 16 base, you see. So, so it will be ABCD will be A into 16 to the power of 3, B into 16 to the power of 2, C into 16 to the power of 1, D into 16 to the power of 0. So how does that work? So A into 16 plus B, A plus this into 16 plus this into 16 plus D. And that becomes your answer. Another thing, so there is something which is called overloading. So what we can do is we can have a max function which takes a double as a parameter, and we can also have a max function which takes int. So this basically is overloading. Okay. So overloading means you have one function, but you have two different signatures or different parameters that you can pass to it. And that actually is overloading. So an example can be two or more possible matches to invocating the function, but the compiler cannot determine which specific match is referred to as ambiguous invocation. That means if you have two functions, it says, max int int and then max double double, and it says max double int. So sometimes what happens is if you pass 1.0 and 1.0, then it means two doubles, then it will take this guy. If you say 1 and 1, it will be int, it will take this guy. If 1.0 and 1, it will take this guy. So sometimes you don't know if you have multiple functions, but they actually are similar. That means if you have two max functions with int, then the compiler doesn't know which one to pick. So that's called ambiguous invocation. So here, you see, so you have max 1 and 2. So you have int double, you have double int essentially. So the compiler may not know which one to pick actually, because a double can be converted to int and an, yeah, and an int can be converted to double. So if the compiler doesn't know which one to pick, that's called ambiguous invocation. Okay. So scoping, this is very important. A local variable is something that is defined inside a method. Scope is a part of a program where the variable can be referenced. Scope of a local variable starts from its declaration and continues to the end of the block that contains the variable. A local variable must be declared before it can be used. So you can develop a local variable and you can have the same name in different nesting blocks in the method. So nesting blocks in the method, but you cannot declare a local variable twice. So example, so if you have int I equal to 0, you can do int j, and this is scope. That means int j can only be used after this, after you define it. And int I can be used totally after you define it, only in this block. Now, assuming I use I here, I cannot use it because it's outside this code block. It's outside this close block. This int will only be valid in this bracket. So it's in this scope. Few things actually. Now scope. Now scope of I is going to be in here, but if you declare it twice, that is an issue. It is fine to declare I two non-nesting blocks. That means it can be declared here and it can be declared here. So you can do it twice. Now assuming you do I here and then you do I again here. Now this I has scope all this and this I has scope this, but there is an overlap of scope. So this is not allowed. This is okay, but this is not okay. So you got to keep this in mind. You can have multiple blocks as they are independent. This is only for this part. So they are not intersecting, not intersecting. So this is intersecting. So not allowed. Local scope. Scope of variables continued. So I is declared here. I is declared here. That's okay. No errors. Fine with no errors. Now I is declared here and x equal to, so I is declared here. No, in this case, x is declared here and x is declared here again. Now, what happens is if you do x again, now x will be this scope and this x will be this scope, but they are overlapping. So, not allowed. Similarly, method abstraction. You can think of method body as a black box and contains the detailed implementation. So, this is method body. This is the header essentially. Now, that's a black box because we don't need to know what is happening inside. You give it an argument, you get an answer. That's how it works. So if it's a function, so int function takes a and b as input. So we don't know what's happening inside, but we know we get an answer. So that becomes, so if you put in values, that takes a and b and it gives you an answer back. So that's your black box, that's your function. So it takes in a, b and it gives you an answer. Benefits of method. You can write it once and reuse it anywhere. Information hiding, hide the implementation. That means your black box is, so you're calculating max value. So the person using it doesn't care how you calculated it. It'll just give you A and B and then it gets the max value from it. So it reduces complexity because what you need to do is now only supply A and B and you get the answer as max value. You can generate random values essentially by using a function called math random. And if you want to generate a lot of values between, so math random actually gives you values between 0 and 1. So when you give and 0 and 1, generating random. So you can actually, how can you generate random values? You can generate random values by, you can take whatever the minimum value is, you can add math random into a value that you want to generate through, essentially. So assuming you want to generate a value between 10 and 20, so what you do is basically you'll say 10 plus math random into 20 minus 10, because this is between 0 and 1. So this multiplication gives you, so this is 10, so it gives you between 0 and 10, and this is 10 plus 0 and values between 0 and 10, that gives you values between 10 to 20. Similarly, so that is what is explained here. Similarly, that's what's explained here, and there you go. So random characters. So this is basically get random character. So this generates random characters essentially between A to Z. This generates between capital A to Z. This generates between 0 and 9. This generates on the Unicode space. Stepwise refinement is a concept which can be applied to process or developing programs. Stepwise refinement to decompose into sub-problems, and more manageable problems. So if you want to print a calendar, and we can actually see how to manage the stepwise approach. So you can do main calendar, but then you can read input and print month. You can do from print month, you can do print month title, print month body. Body is basically the dates. Title is Jan, Feb, March. So you can do from there you can get the month name, you can get, and from there you can get the start date and you can get the number of days in the month. And then from there you can get total number of days, basically start day and total number of days, which actually gives you how many months are there. And then once you get that, you check if it's a leap year or not, basically. So there you go. So this is called a top-down implementation. That means you're going from the top, you're going down. And then, and bottom-up approach is that you start with method, then you go up and finish the program with the test. Benefits of stepwise refinement is simple program, reusing methods, easier to develop, debug. Debug is basically fixing syntax, errors, logic, errors, compile, errors. Simpler programs, better for teamwork actually.